You can easily measure how long it takes for a Python program to execute. So when you run the program itself can measure how long it takes. In this case, this program took 24 seconds. And you can measure the execution time using the time module. So by importing the time module, we can get the start time and the end time. And then when we subtract the difference, we know how long it took for the program to execute. So in this case, we have a simple program that does some addition with very large numbers. So you can use this logic for any program. For example, if we would have a hello world program, we can say import time. We get this start and end time, and then we can do something. For example, the print function, and show the difference. So that would show us the difference in execution time, or how long it took for this line of code to execute. So I can run it, and you'll see it took very few seconds, so 10 to the minus fifth, because the print function is like all it does. So of course, measuring time, when measuring execution time, you want to measure something that actually takes time and not simply outputting a single function call. So for example, a for loop, where you add a value or whatever takes time, right? So you want some function that takes a long time to execute. And then you can measure that function by subtracting the start and the end time, or the end time from the start time. So if we run this, okay, that was really fast. So you want the function to take a while. So let's say we add another function in here. So that way it measures how long the function actually takes to execute. So this is actually all there's to it, measuring the difference in end time and start time using the time module. As with anything Python, there are multiple ways to measure or to do something. So Python comes with a default module called cprofile, and cprofile lets you measure the execution time of a function. So we have a function f, which can be any function, it doesn't really matter, but we load cprofile, and then we say cprofile.run with that function name, and by doing this it will output how long it took to run that function. So instead of the time module, you can also use cprofile to do measurements, to do profiling for your code. So if we run this code, you'll see that it starts measuring how long the function, or how long it takes for that function to complete, and then output the amount of seconds it took. And it will also show you some more information about the calls. So cprofile is installed by default, and it's an alternative to using the time module I showed you before, where you measure the start and the end time and calculate the difference. So cprofile will also give you the execution time of a function. You might prefer one or the other, but in the end, both measure the execution time. Python is an interpreted language, so you write the code, and Python will actually execute that code. As opposed to compiled language, when you have a compiled language, your code is transformed into an executable, and it doesn't need any other program to run. So Python code always runs using the interpreter, the Python interpreter. For example, when we want to run the program program.py, we type python3 space program.py, and here python3 is the interpreter. So naturally, the program will only execute as fast as the interpreter. For example, I have this little program here, which all it does is start measuring, run function, and then measure the execution time. So we can run that using the Python3 interpreter. Now, the execution time may differ on your computer because of some computers are faster than others. So if we run this, you'll see it takes about a few seconds to run it. But the execution completely depends on the interpreter with Python. So it completely depends on Python3 or whichever program you use to interpret the code. So if we try to run it with Python 2, the same program, the execution time can vary. So you'll see now it run a bit faster without us doing any change in the code at all. So the execution time can depend on the interpreter you're using. So you can try like little differences in Python versions to see if that speeds up your code. It's a very simple way to maybe gain a few seconds of execution time just by changing the interpreter. So the execution time of your Python program depends on which version of the Python interpreter, but also on which implementation. So the Python 3 interpreter is made in the C programming language. You can actually view that source code if you want. It's online in github.com, python/cpython, which is the official implementation of the Python interpreter. So they add some information here. You'll see that it's based on the C programming language. However, an interpreter can of course be made in many different languages, and different implementations can give you a speed up. If you go here in one of these folders, for example parsers, you'll see there's actually C programming code in here. So the whole interpreter, Python 3, is written in C. Now there are other interpreters, for example the PyPy interpreter, which is an interpreter made in the Python language, which is generally faster than the regular Python implementation. So you'll see here a comparison between CPython version 2.7 and the latest PyPy version. And you'll see the execution time is significantly lower in a lot of occasions. So for example, if we run this program using the C implementation of Python, you'll see it took 2.6 seconds. And if we use the PyPy version of the program, so if we change that to if we change the interpreter to the PyPy interpreter, you'll see the execution time suddenly dropped by a lot of seconds, right? So instead of 2 seconds or almost 3 seconds, now it took like almost 0 seconds. So it's a different implementation, which has some advantages, for example, speed. So in a lot of cases, it can be faster than using the Python 3 default interpreter. However, when you use C extensions, then it might be slower. But for regular programs, it can be a lot faster, as I've shown here. And so as a comparison, when we use PyPy and the regular interpreter, the execution time can be like significantly different. And we didn't change a single line of code, right? We just changed the interpreter, different implementation of Python, and that made the execution time lots and lots faster. So you can use the PyPy interpreter. You can download it from pypy.org. It's also available in the package manager, and it's available for Linux, Windows, and Mac, and also some custom architecture. So you can download it or you can install it with your package manager, and all it takes to run it is just to change the command from Python 3 to PyPy 3. So that can significantly increase your execution time.